Mars is well and truly back in the news, even though it's not well placed for observation at the moment. Now, we know that Mars is less unlike the Earth than any other planet. But is there any life there? And has there ever been life? We still don't know. We're trying to find out. Various probes have been there, and the latest is NASA's Phoenix, which has come down in the Martian Arctic and is sending back fascinating results. Chris Lintott has been over in America to bring us the latest news.
It's the beginning of the day for the Phoenix team based in Tucson, Arizona. Scientists and engineers have gathered from around the world to work on NASA's latest mission to Mars.
We're going to continue the trenching and the grooming and the cleanup in Snow White, and exactly what we do will depend on what we see. So geology, chemistry, and RA, we can take a careful.
Phoenix was born from the disastrous crash landing of Mars polar lander 9 years earlier. But Phoenix has landed safely and is hard at work on the surface of the red planet. At the end of each Martian day, Phoenix transmits its valuable data to spacecraft overhead, which then relay the information to Earth. That signal takes 18 minutes to travel from Mars to the Earth. Until it reaches us here in Mission Control, the Phoenix team can only wait and see what Mars has in store for them today.
Oh my gosh.
It's beautiful, isn't it?
It's move-in condition.
Yeah.
Triple wide.
The imaging team get a first look at what Phoenix has been up to on Sol 32 of its mission.
Where it drops off the ledge, you see a great impression of the scraping.
There you go.
A Sol is a Martian day, 24.5 hours long.
No.
What Rich was pointing out, that ledge there.
Excellent.
Today, Phoenix has spent most of its time digging. The aim is to reach the hard layer of ice the team has discovered just a few centimeters underneath the dusty surface.
As soon as these pixels are on Earth and they've made their tens of millions of miles journey here, what I want to do is get them to the team as soon as possible.
Okay.
And so what I'm doing right now is putting them on a directory so they're convenient for Carrie to load up onto that other computer.
Okay, and
then the whole group can take a look at them. For instance, the robotic arm team, you'll see them keep popping in here to be able to take a look because they need to know where the arm ended up. They've got their telemetry.
In order to plan for tomorrow.
And they need to know how it worked. And again, if it's too hard, that is, as we're scraping here, if they hit something that's too hard, the arm has safeties built in that says, hold it! Too hard, you've got too much stress here, stop. If it stops, they have to go through an extra routine to get it back into operation. So that's why they want that information, because if they can just move ahead, then we'll do more scraping and cleaning tomorrow.
Oh, that's a steep back wall, isn't it?
Oh yeah.
And that really did dig in at the front there.
Stereo images like this one help the science team monitor the progress of the arm as it digs into the Martian dirt. There is also a camera on the arm itself. This image shows Martian soil successfully collected back on Sol 15. The instruments on board include everything from a chemistry lab to a weather station. Professor Peter Smith is in charge of the mission, which has been a roller coaster ride.
Even 31 or 2 days into the mission, we finally got our wet chemistry data yesterday, and the whole place erupted in cheers. And it's been that way for a month. I mean, the mood is just electric because we go between the high of new data and, the possibility of really interesting scientific discoveries, and then kind of these complications with communication path problems or, a software bug or something that slows us down. And so there's kind of this, yin-yang of the joy and the sorrow of all that accompanies any great adventure, There's no great adventure, there's just all joy. It's always with a lot of pain and sorrow mixed in. So we're doing really well. We're meeting our goals, we're on track. And I'll tell you, one of the greatest thrills was looking back under the lander and seeing the thrusters that cleaned off the ice layer. I mean, that was what we were looking for. We were told there's ice from the orbiters. The theory says it's going to be down 5 centimeters. And we look underneath and the thrusters had done our job for us. There it was.
Even before you'd started digging, you knew there was ice there.
Even before we started digging. We didn't have to dig an inch. And yet we can't reach that ice because the struts and things under the lander prevent the arm from going under there. So it's there, but we can't touch it.
Main engine start, 2, 1, 0,
And liftoff of the Delta II rocket with Phoenix, a distant science outpost seeking clues of the evolution of polar region Mars.
Launched in August 2007, Phoenix's journey took nearly 10 months before the spacecraft reached Mars on May 25th. At the Jet Propulsion Laboratory, where Peter and his team had gathered for landing, tension was understandably running high.
The atmosphere was electric, I'd have to say, because we had been prepared for months and months for all the contingencies that might go wrong. In fact, I'll tell you a little story. The press representative of the Jet Propulsion Lab had prepared press releases for every single thing that could have happened incorrectly and caused a bad day for us on the landing day.
So you already had written down, it failed because of whatever.
Yeah, exactly.
Altitude 2,000 meters. Altitude convergence detected.
And so as we went through each one of these transitions, he was tearing up those press releases and throwing them up in the air. So there was this confetti coming down of all the press releases we didn't have to give. It was a joyous moment.
Circling overhead, Mars Reconnaissance Orbiter managed to capture this amazing image of Phoenix during its descent, and later saw it, its parachute, and its heat shield on the surface. The view from the lander shows the Martian Arctic to be flat and nearly featureless, but you can see patterns called polygons. These are caused by the continual expansion and contraction of the ice under the surface, and it's this ice that Phoenix has been sent to sample. One of the key instruments on board Phoenix is Mecha. Mecha's toolkit includes a very small but very sophisticated chemistry set. The Mecha team are poring over data from their first soil sample, trying to decipher their instrument's messages from Mars.
It's a high technology with very simple chemistry. We do pH measurements. I mean, pH measurements are something we do in Chemistry 1.
Yes, with the litmus paper.
With litmus paper or with an electrode. So this is basically the same sort of sensor in here. There are 3 pH sensors. Well, first of all, we put water in here. We thaw the water goes in there. Then the robotic arm scoops the soil. The drawer opens up, takes some of the soil, closes, and then the soil drops into the chamber here. Right. At that point, it's stirred. There's a stirrer mechanism here. And all the sensors start to monitor what's happening in that mixture of soil and water. So we're reconstituting the soil. We're taking it with water. It may not have seen water for 1 million, 1 billion, 2 billion years. We don't know. It may have been a long time. So we're reconstituting its aqueous form.
So you've had 1 sample delivered so far?
So far, yes. We've done our first experiment, and it's about 80% complete. And the first part of it was done yesterday. It gave us the amazing results for the science community, the first taste of Mars.
And what were the results?
The first taste is that Mars is I guess you would call it bitter. It's an alkaline. It's a pH of somewhere around 8, maybe as high as 9. So it's an alkaline soil at the point where we sampled anyway. And it helps answer a little bit the question of how friendly to life is the soil on Mars. And right now, looking at these values, we're saying this is friendly soil. It's not extreme. It's not sulfuric acid mixed in with bleach. It's slightly alkalinic, but it's reasonably good. So in fact, the amazing thing is that this planet is not an alien planet. It's actually very much Earth-like as far as I can see right now.
Parts of the landing site around Phoenix have been given names from fairy tales, including Humpty Dumpty. Mecha's microscope has looked at soil from the trenches Goldilocks and now Snow White, each of which was delivered by the robot arm scoop.
The scoop comes in, it comes over the top of here, and we developed a special technique so that we get just the right amount of soil. Originally, we were just going to dump a whole scoopful on here, and that would really overwhelm what we're trying to get here, which is just enough particles to see them individually, not so much that we just clutter up the entire field. So what we developed was a way of essentially getting our scoop here and then giving it a little vibration so that just a few of the large volume of material, just a small proportion of that would then go on to our substrates. We came out with our tongue sticking out, as we said, and the material landed on there, and then we took that round, and that was our first set of images that we got back quite early on in the mission. Now, subsequent to that, as we've been deciding where we want to dig, we've been looking at the surface sample, we've been looking at just the top couple of centimetres.
What will you do when the team get down to digging into what we now know is water ice?
We're very interested in seeing what we can do with the optical microscope. In fact, we're doing some experiments in the lab at the moment because the problem with ice on Mars is that it's not stable. It's subliming, it's turning straight from a solid into a gas.
As soon as you bring it up onto the surface?
Yes, so it's a race against time. We've got about, at most, a couple of hours to get the material, to get ice in so that we can see it. And then we'd love to do some time-lapse photography if that would be possible.
I think you're the only person in the room I'd recognise the instrument of if I saw it, because we have a model sitting here. Tell us what this is and how it came to be on Mars.
This is the telltale or model of the telltale wind indicator, right size, sitting on top of the meteorological mast. And it is recording the winds around the landing site. And this is a very sensitive instrument. You won't see it fluctuate that much on Mars, but that is because of the low pressure on Mars. Only 1% of the air pressure we recognize on Earth.
So how did you come up with such a simple idea to measure the wind?
The idea was actually born by Carlos Lange sitting over there. Carlos, come over here.
There we go.
Carlos here came up with this crazy idea of putting something sitting in fibers, measuring winds on Mars.
Okay, so tell us the story. How did you end up with this idea?
Well, the problem was that the original anemometer was cancelled very late in the preparation for the mission, and we could not add any sophisticated instrument that had an electronic interface. We had to have something that the camera could capture moving on Mars. And that's very tricky because the atmosphere on Mars is so thin that the instrument has to be very sensitive to move. And this sensitive instrument has to survive a really bad beating on the trip to Mars.
Even with your successful landing.
Right, and the landing. And on Mars, then the UV radiation hits on it without any protection because Mars doesn't have ozone layer.
I guess it's the highest man-made thing on Mars.
On Mars currently,
It must be the highest point for a long, long way, because Phoenix is landing on some pretty flat plains, so you better watch out for Martian mountain climbers.
So, how much data is in the T-Lights?
Behind me is an exact replica of Phoenix. The team use it to work out solutions to any problems that occur. With the real thing 200 million miles away, even the smallest problem could quickly cause a major headache. TIGA is the most important instrument, the star of the show for the Phoenix mission. Soil is delivered to the TIGA ovens by the robot arm, where it's slowly baked to more than 1,000 degrees centigrade. As the soil is heated, any gases given off are tested for chemicals, including water ice and organics, both necessary for life. It's also the instrument which has been beset with the most problems. First, the soil was too clumpy to get into the oven. Then they had problems with the oven doors. Every day, Mars throws more challenges at the TIGA team. Professor Bill Boynton, the principal investigator, remembers the moment they finally got some good news.
When the data came down, we kind of kept it secret until we had the midpoint meeting about an hour later where people talk about the results. And we'd gone to this meeting 3 or 4 times talking about, well, no, it hasn't worked, and no, it hasn't worked again. And so this time I started off by saying, yeah, we got some unfortunate results. The process terminated early, and usually when a process terminates early and aborts, it means something wrong. But this time I said, well, the reason it terminated earlier is because that's what it's supposed to do when we get a sample. And so it was a big celebration, and I was actually doing a little dance to shake your booty because we've been shaking this thing so much. It was a lot of fun.
And it works, and we're ready to go forward to get more samples. Has there ever been an experiment like this on Mars or on any other planet?
Well, a long while ago, the Viking missions did something similar. They took some soil sample and they heated up rather quickly to 500 Celsius and looked for the gases given off, and they did not see any organic molecules. Now we're doing a few things differently. One, we're going to 1,000 degrees rather than 500. The other is we're heating up slowly so we can see if gases are released at different temperatures. That can help us understand what we're seeing there.
And you're in a different place.
And that's another important difference. We're in a different place as well. So we're thinking there's a good chance we might see organics here that either might have been present in the Viking sites, but just too refractory that they didn't vaporize at 500 degrees, or it just may be that the polar regions are more conducive to the organic molecules surviving.
The results from the first sample are still being pored over by the scientists. The TIGA team are waiting to get into the subsurface, where they know frozen water exists. Then they may start to unlock the secrets of Mars. In the meantime, the robot arm keeps digging, getting ever closer to the ice layer. When the TIGA oven melts this ice, the water released could once have washed the shores of Martian continents.
The first stage of looking for life on Mars is to find water. Life and water are so closely associated on the Earth that finding water is the first thing you have to do when you're searching another planet or a moon around a big planet. Where's the water? That's where you're going to look first. So we found the water. It's ice in the polar plains. The next step, is it a habitable zone? And habitable to us means first the liquid water, then all the materials, the basic building blocks and ingredients for life, including organics, organic molecules, carbon chain molecules, complex ones, not simple ones, and then the various minerals that are elements that make up the complex organic chemistry of our bodies. And that's sulfur and carbon and hydrogen, nitrogen, phosphorus, oxygen, all those things. If they're all there, then you can say all the ingredients are here. This could be a habitable zone. Are there energy sources too? Chemical energy, of course the sunlight. And if all of that's available, then you can start to say this is a habitable zone. Now, the next step is within that habitable zone, which may be the entire polar region, where are the habited places? Where's the life forms? Now that might be quite a search.
You're looking at one small patch of the surface.
We can only reach with a 2.3 meter arm. We can't do much of a search. You need rovers or some way of detecting from space.
It's the end of the day, and the team are preparing tomorrow's orders for the spacecraft. In only a few months' time, Phoenix will be enveloped in a shroud of carbon dioxide ice, ending its mission. Who knows what we'll discover before then?
Well, it's fascinating. Phoenix is working well, and of course, we'll keep you posted. Meanwhile, it's newsletter time. If you want a newsletter, send your stamped, addressed envelope to Sky at Night Newsletter, BBC, Birmingham, B1 1RF. And next month, Chris will be back in America telling us about the Large Binocular Telescope. Until then, good night.